Good day, and you're welcome back to my channel. Like you know, this is Edinburgh Academy YouTube channel. Now, in the last video, we discussed resolution of forces into different ways. The ones acting in the same direction, different direction, inclined at angle to each other. Resolution of vector to both horizontal and vertical component, and finally coplanar forces, different forces acting at a point. And I promise I'm going to draw the part 2 of the video, which is unit vectors. Now this is the part that students find very difficult. But trust me, this is the simplest part of it. In fact, I prefer this part to the first part. Although both are simple, but this is very, very easy to solve. Now for unit vectors, this is like what unit vectors are actually doing is they represent points. That's it. Just one point without units. When you said a point without unit, you are referring to a unit vector. Because unit means one, or the least of what you can have. So let us just say one. So now when we say unit vectors, it means they're vectors that are represented in different form, representing different points. Now for coordinates, in coordinates we have the x-axis, the y-axis, and we can as well have the z-axis. Just look up, we have something like this. This is the y-axis, this is the x-axis, and any other axis represents z. This is exactly what we do in unit vector. So for unit vector, instead of having x, y, z, we're going to be having I, j, and k. It means whenever you see I, it represents that that vector moves in the x direction. Whenever you have j, it means the vector is acting in the y direction, and z means it's going, and k rather means it's going in the z direction. That is just what it means. No more, no less. Now, we have three things to do for vectors represented in this form. And you always see it this way. Vector A as component of I plus 2j minus 3k. Like this. That means vector A has 1 in the x direction. Vector A still has 2 in the y direction. And this same vector A has minus 3 in the z direction. This is I, j, and k. You can see just one I means I plus 2j minus 3k. That is exactly what it means. Now we perform different operations, or let me say just 3 operations on vectors, unit vectors. We have addition of vectors, we have subtraction, and we have multiplication of vectors. There is no division of vector, because division of vector is infinite, so there is no division of vector. So you have 3 operations that are going to perform on unit vector: the addition, the subtraction, and multiplication. Now when you want to add vectors together, you add based on their components. If you have 2 vectors now, for instance, vector A has component of 2I minus 3j plus 4k, and vector B has component of 2j plus 5k. Now if you look at this vector very well, vector A has 3 components, while vector B has just 2 components. Then if the question says find A plus B, that means you are adding vector A and B together. Now when you add 2 vectors together, you are going to have another vector. That means your answer or your resultant will also be in form of vector. So let's see what we have. We're going to have, since we are having just I for A, we are not having I for B. So we consider that the I for B is 0. So to be 2I plus 0. I hope you understand, because we are adding according to their components. So we add all the I components together. We add all the J components together. Likewise, the K component, we add it together. So 2I, since B has no I, it is 0. So 2I plus 0 will give you 2I. Then move to J. For A, it is minus 3J plus 2J. Minus 3J for A and plus 2J for B. Minus 3 plus 2 will give you what? minus 1. Minus 3j plus 2j, it gives you minus j. It is minus 1j, but you can write it as minus j. Now, for k, we have plus 4k plus 5k, give you plus 9k. That is just adding two vectors together, as simple as that. But don't forget, this is just the resultant. Sometimes you may be asked that to find the magnitude of resultant. Don't forget, we have scalar and vector quantity. Magnitude means size, because scalar quantity has magnitude, no direction, while vector has both magnitude and direction. So when we're talking about anything magnitude, it means just a single value. You can have 10 inputs and 1 output. That single output means the magnitude. So here we have vector form, which is the resultant, but we are asked to find magnitude of the resultant. Just say the magnitude of the resultant a plus b is equals to the square root of 2 square, you pick one after the other now, plus into bracket minus 1 square, because what you have before j is minus 1. Then the last one plus 9 square. This, if you add everything together and you square it, it gives you just a single value, and that represents magnitude of resultant. This is your resultant, and this is the magnitude of resultant. That's how to add two vectors together. That's simple as that. Now, what if it's subtraction? Let's use the same vector to perform operation on subtraction. You may be asked in two ways. It is either they give you that find a minus b, or they tell you subtract b from a. Subtract b from a is not b minus a. Don't make mistakes. And I trust University of Unilorin, if you do b minus a, the answer will be in the option. So you think you are right, because the joy of every student is to calculate and find their answer in the option. It is not every time that your answer is right. Just make sure you do it as required and in the right way. So a minus b now. This is what we are going to do. You write all the a out. 2i minus 3j plus 4k. Then you write all your b together. But before you write it, make sure you put the negative sign. Minus, then open the bracket, because negative is a very dangerous sign. 2j plus 5k. Then close it and open the bracket now. You now have 2i minus 3j plus 4k minus 2j minus 5k. Then you collect the like times. Then is equals to 2i, we don't have another i, it remains 2i. Minus 3j minus 2j gives you minus 5j. Then plus 4k minus 5k gives you minus k. It's minus 1k, but it's minus k. This is your a minus b. So if you're asked to find magnitude of resultant, this is the resultant. If you're asked to find magnitude of resultant, just say you have a minus b to be equals to the square root of 2 square. You pick their coefficient this time around, like we did for the previous one. Plus, open bracket, minus 1 square, although it will later change to plus. Then finally, plus into another minus 1 square, because, okay, this is minus 5, sorry. Minus 5 square. So you do the operation and you have your single output. So this will give you magnitude of resultant, and this is resultant. So this shows that when you add two vectors together, the resultant will be in a vector form, but the magnitude will be just a single value. Likewise, when you subtract two vectors, the resultant will be in a vector form, but the magnitude will be a single value. That's simple as that. Now, they may not give you in form of ijk, like in form of vector a, vector b. They may give you in form of any other thing. For instance, take this question. Look at the question on your screen like that. I hope you can see it clearly. You have addition of vector. But they said given two displacements, vector A, you can see the sign on vector A. It shows it's a vector quantity. Is equals to 8i plus 3j minus 2k. Everything in meters. And B, you can see the sign on B as well, is equals to 4i plus minus 6j, plus 8k. Everything also in meters. And they said find 3a minus b. Find 3a minus b. Now you can see the question clearly. Now, don't forget, they said find the magnitude of the displacement 3a minus b, not just find 3a minus b. So we are finding the magnitude of 3a minus b. All right, now you can see it on the board. What you are just going to do is you open the bracket of a with 3. Remember, this is not multiplication of vector. If you are multiplying two vectors, the two vectors you are multiplying with each other must be in vector form. So using this 3 to open this bracket is not multiplication of vector. No, we are just opening the bracket. So 3a now, 3a will give us 3 times 8 will give us 24i plus 3 times 3 9 plus 9j. 3 times 2 is 6 minus 6k. Everything in meters. Then our b like that. So if you are going to b is just remains b, there's no coefficient to open it. So for us to find 3a minus b now, we're going to write out all your a that you have just gotten by multiplying 3 by the bracket. So it's going to give you 24i plus 9j minus 6k minus, then you write your b, 4i minus 6j plus 8k. Then we open bracket, we're going to have 24i plus 9j minus 6k minus 4i plus 6j minus 8k. Then when you simplify or when you solve it out, you have 24i minus 4i. That's going to give you 20i. Then you have plus 9j plus 6j. That's going to give you what? Plus 15j. Then you have minus 6k minus 8k. That's going to give you what? Minus 14k. Now, this is just your resultant, which is 3a minus b. And the question says, find the magnitude. Be careful. Find the magnitude. So we're going to find the magnitude of this by saying we have it as magnitude is equals to the square root of 20 square plus 15 square plus open bracket minus 14 square. What do you have with your calculator there? That's the answer. That's just how to find magnitude of the result. You can see they didn't put it in form of a equals this and that. They gave you in form of two displacements, and you're asked to find the magnitude of 3a minus b. That's just addition of vector, and you have the subtraction also the similar way. Now let's move to multiplication of vector. You can multiply vectors in two ways. We have the first one, which is the dot product. And the second one is cross product. The dot product can otherwise be called scalar, while the cross product can be called vector. Of course, they both means multiplication, because in mathematics, if you have a dot b, it means a multiplied by b. If you have also a multiplied by b, the same thing. But in vector, we approach them differently. Subscribe, like, share my videos, and put on notifications so that when I drop videos on this, you'll be notified. Thank you.